Hi, it's Mrs. Scarpel, and in this video we are going to solve some word problems that have variables on both sides of the equation. So just a reminder, we need to understand the problem. That means identify what it's asking us to do, but also look at what information we're given and what information might be missing. Then we're going to make a plan. What can you use to model the problem? That's our equation we're going to write. And then we're going to solve the problem and then check to make sure the answer makes sense. So let's take a look at example 4. We have a boat that leaves New Orleans and travels upstream on the Mississippi River for 4 hours. So I'm going to make a note that the time, because that's what 4 hours is time, upstream is 4 hours. The return trip only takes 2.8 hours because the boat travels 3 miles per hour faster downstream due to the current. So in that second sentence, we're given the time downstream. But we're given a description of rate in comparison to the rate upstream. So I'm going to describe the rate upstream, because I don't know it, with the use of a variable. And I'm going to say that my rate upstream is r miles per hour. And then I can write an expression for my rate downstream by comparing it to that rate upstream. So 3 miles per hour faster would be an additional 3 miles, so r plus 3 miles per hour. Now, because we have this trip that we're taking upstream and then returning back downstream, that distance is the same both directions. So we're able to write an equation of relating distance upstream to distance downstream, and we have this reminder that distance equals rate times time. So if I take the rate upstream, which is r, and multiply it times the rate, or times the time upstream, which is 4, I can set it equal to the rate downstream, which is r plus 3, times the time downstream, which is 2.8. And then I can simplify each side of the equation, so we have 4r equals, on the right side of the equation, we will need to distribute the 2.8. So that is 2.8r plus 8.4. Then we want to isolate the variable to one side of the equation. So I'm going to subtract 2.8r from each side. And that will give us 1.2r equals 8.4, and then we can divide both sides by 1.2. And we will get that r is 7, and that's a rate of miles per hour. Now, if we go back and check the problem, the question is asking how far does the boat travel upstream, not how fast does the boat travel upstream. So if we go back and we look at distance upstream is rate times 4, well, we have the rate of 7, and if we take that times 4, seven times 4, that will give us our distance of 28 miles. And we can check to make sure it's the same distance downstream. 7 plus 3 is 10, and 10 times 2.8 is 28. So we have solved this correctly, and our answer makes sense. Let's take a look at another problem. In this problem, you want to paint a piece of pottery at an art studio. The total cost is the cost of the piece plus an hourly studio fee. So you're going to look at two studios. Studio A charges $10 for the vase and $8 per hour. Now, whenever you see per hour, that means you're paying something for each separate item. And Studio B charges $16 for the base and $6 per hour. Write an equation and solve for the number of hours it takes for the total cost to be the same. So I'm going to, similar to the last one, distinguish what each side of my equation is going to represent. So I'm going to compare Studio A with Studio B. In Studio A, we know that we're paying $10 for the vase, plus $8 per hour. Well, I'm going to make a note that I'm going to use H to represent the number of hours. So if it's $8 per hour, that means for every single hour I'm there, I'm paying $8. So that's going to be 8 times H. And then at Studio B, we pay more for the vase, so $16, but we pay less for each hour we're there. $6 per hour, so 6 times H. Let's isolate our variable to one side. I'm going to subtract 6H, just because I like to keep the term that has the variable positive. So 10 plus 2H equals 16. And then isolate the variable term, subtract the 10. So we have 2H equals 6. Divide by 2. And we get H equals 3 hours. Now if I go back and check, I am being asked to solve for the number of hours it takes for it to be the same. Going to just mentally check here real quick to make sure it works. 8 times 3 is 24. 24 plus 10 is 34. 6 times 3 is 18. 18 plus 16 is 34. So at 3 hours, it'd be $34 for each place. So 3 hours is the answer to our problem. I would like you to take the time to solve these two problems. And once you have solved these two problems, I will show you how to solve them and what the answers should be. Now that you've had a chance to solve these two problems, this is how I would recommend that you set them up. So we have time upstream is 3.5. We have the time downstream is 2.5, and it's traveling faster downstream than upstream, so our rate upstream is going to be R miles per hour because our rate downstream is a comparison to the rate upstream. And that is R plus 2 miles per hour. So we again are going to have distance up compared to distance down. That's going to be rate times time up equals rate times time down. So R times 3.5 up is going to equal r plus 2 times 2.5 down. And then we can distribute, and we will have 3.5r equals 2.5r plus 5. Isolate the variable to one side. And we end up with the rate upstream is 5 miles per hour. And again, the problem was not asking for any sort of rate, it was asking for a distance. So to find that distance upstream, we need to take that 5 times 3.5 for a total of 17.5 miles. And then we have, you're paying a cable company while your friend is paying a satellite company. So we are comparing Rob You Blind with arm and leg to see how many months. So our variable here, I'm going to use M to represent the number of months. How many months before the cost is the same? So you pay Rob You Blind $45 per month. So $45 for each month, so that's going to be 45 times M. Your friend has to buy a receiver for $99, and then they pay an additional $36 per month. So 99 plus 36M. Then we need to subtract 36M, and we have 9M equals 99. Divide by 9, and the number of months is 11 months. So after 11 months, you and your friend would pay the same, or would have paid the same amount for cable and satellite. After that, it would be different. So you may want to determine if in the long run, is it better to stay with cable, or should you switch to satellite? Or your friend might want to decide, is it better to stay with cable or switch to satellite? So here's some examples of using equations that have variables on each side.